The concept of the standard enthalpy of formation is very important in chemistry, but it is a little bit difficult to understand because it requires the students to combine several concepts together. I will try my best to help you to understand this concept. First, let's start from the definition. The standard enthalpy of formation of a chemical is a change of enthalpy of the reaction that forms 1 mole of that chemical from its most stable elements with all substances in their standard states. The first point to understand this concept is the standard enthalpy of formation is a property of a chemical, just like color is a property of an object. It is very normal if you ask people, what is the color of the dog? People can also ask, what is the color of your t-shirt? But it will not be normal if you ask people, what is the color? Similarly, in chemistry, it is very normal if you ask, what is the standard enthalpy of formation of carbon dioxide gas? It is also normal if you ask people, what is the standard enthalpy of formation of water liquid? But you will not get an answer if you ask people, what is the standard enthalpy of formation? The second point to understand this concept is the value of the standard enthalpy of formation of a chemical can be obtained by using a chemical reaction. This is similar in this analogy. The length of an object is obtained by using a ruler. In other words, if you want to know the value of the standard enthalpy of formation of a chemical, you have to find a chemical reaction first. The third point to understand this concept is the length of an object is the reading on the ruler. Apparently, this is an analogy. Similarly, in chemistry, the value of the standard enthalpy of formation of a chemical is the value of the standard enthalpy of reaction of a special chemical equation. Now let's use sodium hydroxide solid as an example to illustrate how we can find the value of the standard enthalpy of formation of a chemical. As we just learned, if you want to find the standard enthalpy of formation of sodium hydroxide solid, you have to find a chemical reaction first. The chemical equation that defines the standard enthalpy of formation of a chemical must meet 2 requirements. The first requirement is the requirement of the product. The second requirement is the requirement of the reactants. The requirement of the product is it has to be 1 mole sodium hydroxide solid because we're trying to define the standard enthalpy of formation of sodium hydroxide solid. Therefore, sodium hydroxide solid must be the product, and it has to be 1 mole as well. The second requirement is the requirement of the reactants. The reactants must be the most stable elements of sodium, oxygen, and hydrogen. Because if you look at the molecular formula of sodium hydroxide solid, it contains sodium, oxygen, and hydrogen. Therefore, we need to find the most stable elements of these 3 elements. As I asked you to memorize since chapter 1, you had to know the molecular formulas and the states at room temperature of the most stable elements in the periodic table. If you remember that, the molecular formula of the most stable element of sodium is Na. The state of the most stable element of sodium is solid at room temperature. The molecular formula of the most stable element of oxygen is O2. The state of the most stable element of oxygen is gas. Similarly, we know that the most stable element of hydrogen is H2 gas. Therefore, if we want to define the standard enthalpy of formation of sodium hydroxide solid, we have to write down a chemical equation first. We know that any equation will have a standard enthalpy of reaction. You have to carry out that reaction to obtain the value of the standard enthalpy of reaction of that reaction. That value is the value of the standard enthalpy of formation of that chemical. Now let me put down the equation. For any chemical equation, you have to make sure it is balanced. Because from the definition, to define the standard enthalpy of formation of sodium hydroxide solid, the product has to be 1 mole of sodium hydroxide solid. Therefore, you have to use fractions for the reactants. The value of the standard enthalpy reaction of this chemical reaction can be obtained by carrying out this chemical reaction. Let me use more examples to explain this concept, because this concept is a little bit difficult to understand. If you want to give the definition of the standard enthalpy of formation of calcium carbonate solid, the product is always 1 mole of calcium carbonate solid. The reactants must be the most stable elements of all elements that can form calcium carbonate, which is calcium, carbon, and oxygen. We have to balance this equation by putting down appropriate numbers in front of each element. Well, let me use another example to explain this concept. If you want to give the definition of the standard enthalpy of formation of ammonium phosphate solid, you always put down 1 mole of ammonium phosphate solid as the product. Then, on the reactant side, you have to put down the most stable elements of all the elements that can make up ammonium phosphate, which we have 4 different elements. Then, you need to balance the equation. As we know, every chemical reaction will have a standard enthalpy reaction. The standard enthalpy reaction of this reaction can be obtained by carrying out this reaction and calorimetry calculations. The standard enthalpy formation of ammonium phosphate solid is equal to the value of the standard enthalpy reaction of this chemical equation. Sorry, I forgot to write down this part for the standard enthalpy of formation of calcium carbonate solid. Let me put it down right now. Well, let's look at the last point. The standard state refers to pure solid, pure liquid, or pure gas at 1 bar. 1 bar is the pressure and any temperature. There is 1 standard state at each temperature. Therefore, for any substance, there will be infinite number of standard states. But the standard enthalpy of formation of the chemicals are given at 298 Kelvin.